And lastly, let's look at the standard enthalpy change of combustion when you have that type of data given. So this is an equation, and I want to show you how to form your your last line. So by the definition of combustion, it is when a substance is burnt in oxygen under standard conditions in their standard states. So carbon is in its standard state, and therefore when we burn carbon in oxygen, we are going to get CO2, which is carbon dioxide. And because one carbon forms one carbon dioxide, if two carbons are burnt, then they give two carbon dioxides. Therefore, if four carbons get burnt, we're going to get four carbon dioxides. So here we're going to get four. Similarly, when I burn hydrogen with oxygen, I'm going to get water. And if one hydrogen burns with oxygen, it gives one H2O. Therefore, five hydrogens will burn in oxygen to give five waters, for five water molecules. So we'll write five here. And in combustion, our arrows are always going to be pointed downward. So just as we did in our previous data, let's write down what we have. So on this side, we've got, because it's combustion, instead of F, I'm going to write a C. And we've got four lots of carbon, so we're going to save that, plus five lots of H2O. And on this side, we've got C4H10. So remember, to form the bottom line, we just need to burn this in oxygen to give us the values, and it's always going to end up as carbon dioxide and water. It cannot form anything else. And suppose if you had a oxygen here, oxygen cannot burn with oxygen, so it's just left alone, and you still have carbon dioxide and water. So now let's decide our direction. So we can see that this arrow and this arrow up. Oh, I forgot to mark the x. So this is our x. This is what we are asked to find out. The standard enthalpy change of formation. So it's standard enthalpy change of formation because in order for it to become butane, which is C4H10, it's made up of it's made up of carbon and hydrogen. Therefore, you have carbon and hydrogen. Whereas in formation, it was a combustion because CH4 is burnt in oxygen to give carbon dioxide and water. So the question, instead of asking find the standard enthalpy change of reaction, it could ask find the standard enthalpy change of combustion, and they would give you a standard enthalpy change of formation data table. So this is how you would form it. And in this case, they would give you standard enthalpy change of formation and give you a standard enthalpy change of combustion data table. So that's why I mentioned earlier to make sure what data table you have been given. Okay, so let's decide one direction. So because this arrow and this arrow are going in one direction, I'm going to call this as, oh, I'm going to call this, I'm going to call this side as delta H1 because it's clockwise, and this goes in an anti-clockwise direction. So I'm going to call that delta H2. And from Hess's law, we know delta H1 is equal to delta H2. So let's put in our information for delta H1. So in delta H1, we have X plus we have the product side, which is delta HC theta C4H10, as we have written down here, equals to on this side of the arrow we've got 4 lots of carbon plus 5 lots of H2. So now that we've got our equation, let's plug in all the information. So we've got X plus C4H10 from the data table is given, its value is negative 2877, and for carbon it's negative 394 plus 5 times for H2 it's negative 286. So now that we have got our values plugged in, we are now going to calculate. So we are so on this side we would get negative 1400 and sorry, on this side we would get negative 1576 minus 1430, and this will go to the other side to become plus. So you've got plus 2877. Therefore, X will be equal to negative 129 kilojoules per mole once you calculate all of this. So this is how you would calculate the standard enthalpy change of combustion. Now there's the same type of question that is the standard enthalpy change of combustion, but they have given another element as X. Even in this equation, suppose if they had not given us the data value of C, of carbon that is, let me rub this side so that I have some space to write down. Okay, so here the question is, yeah. So here they're asking us to find the value of C. Now, they have given us, okay, so they've not told us what carbon is, but they've told us what H2O is, what butane is, and what the standard enthalpy change of reaction or formation is. So now using the same Hess cycle, using the same values, we're going to calculate this. So say suppose we never did this type of calculation down here. Now we are still going to take it as delta H1, delta H2. So we're going to copy the same exact sentence that we wrote here because nothing changes. It's still going to be the same. So we're going to we're going to say delta H1 is equals to delta H2, and we have X plus, so we're going to put this as X, not delta HR, so that we don't get confused. X plus standard enthalpy of combustion of butane is equal to 4 lots of delta Hc of carbon plus 5 lots of delta Hc H2. Okay. So now we know what this X is. We know that this is 129. We know what butane is. Butane is negative 2008. But we don't know what carbon is. So this is going to be our X now. So instead of standard enthalpy change of combustion of carbon, I'm going to put it as X, and I'm going to keep the 4 with it. Plus, we've got 5H2O, so we've got 5 times negative 286. So now let us calculate this. I didn't mean H2O, I meant H2 and I said before. So calculating this side, we get negative negative 3006, and calculating the other side we get 4x minus 1430. Now let us bring this to the other side. I'm going to extend this line more so that there is some division. I'm going to extend this more, and I'm going to bring this to the other side. So um it's going to be negative 3006 plus 1430, which gives us 4x. Calculating this side, I get negative 1576, and I'm going to bring this 4 here, so it's going to become a divide equals x, and when I divide that number, I'm getting x is equal to, let me come down, so therefore I'm getting x is equal to negative 394 kilojoules per mole. And now if you have a look at your data table that was given for this question, you can see that carbon is negative 394. So you can see that although they have given different values, you can still find out the elements. You can find out the reaction, the enthalpy change of reaction, and all of that. It's all the matter of knowing what is your X, and knowing um, what type of data is given. And that brings us to the end of enthalpy and Hess cycle.